Hi viewers, welcome back to my channel. In my earlier videos, I explained how to develop isolated flat and isolated tapered footing layout plan. In high-rise buildings, we will design the footings as step footings. Now I am going to explain how to develop the step footing layout plan.
This is my step footing schedule file. I am opening this file, selecting the column sheet. Here I am selecting all the columns. Then select data, filter. I am filtering with respect to Y quadrant, removing this blank. It will segregate all the foundation level columns. I am hiding these columns. Before entering column ID and footing ID, we should do grouping of columns and design of footing. I am assigning column ID as C1 for the members 1 to 8, C2 for the remaining columns. I am entering footing ID as F1 for the members 1 to 8, entering F2 for the remaining. Removing the filter command, then unhiding the column. Then select footing sheet. In this sheet we have to enter the footing design data. I have two groups, F1 and F2. F1 I am assigning 4000 by 4000 by 900 mm depth for the first step, 2000 by 2000 by 600 for the second step. For F2 I am assigning 5000 by 5000 by 900 mm depth for first step, 2500 by 600 mm depth for second step. Here I am assigning pedestal size 750 by 750 by 600 mm for both F1 and F2. I am assigning pedestal reinforcement 12 mm at 8 numbers. Stirrups 8 mm at 200 center to center spacing. I am assigning bottom reinforcement for F1 12 at 150 mm center to center in both ways. For F2 I am assigning 12 at 125 mm center to center in both ways. Selecting COL RF sheet. By default there will be only one column. Column size will be taken from the column sheet. Here I am assigning column ID C1. Here I need to enter terrace level. In my project my terrace level is 9 meters. Here we have to assign the dia of the bath and arrangement of the bath. For C1 I am assigning 16 mm dia at corner. It will be reflected in 4 corners. Here it is showing 4 number 16 dia, and I am assigning additional 12 mm bath. For 16 plus 4 12 is provided. Here it is showing numbering V1, V2, V3, V4. If I want to connect internal bus with one ring, here we need to enter V2-V3. I am copying C1 data and pasting below the C1. There should not be any gap between C1 and C2. I am modifying this C1 as C2. Here I am assigning 16 mm bar at center. Means in first row I am assigning 3 numbers of 16 mm dia that will be mirrored in other direction. 6 numbers 16 dia it was reflected, and 4 numbers 12 dia already is there. Here I am showing value H2. If I want to connect a link here, then I need to enter here H2 hyphen H2. If the number is same, it will consider as a hook. If the number is different, it will consider as a ring. By default, master ring will be generated automatically. I'm closing this file. Coming back to my command prompt, I'm entering my command DET. This is the main screen. Here I am selecting footing layout. By default text height will be 200. If you want to change, you can change the value. Draw in units. By default it will be mm. If you want to draw your drawing in meter, you select meter. If you want to draw in inches, select inches. Here I am selecting mm. Clicking OK. I am selecting my Excel file, step footing schedule. It will read the data from that Excel file. Asking pick point for printing footing layout. Here I am picking. It will generate the footing layout plan as per that Excel file data along with schedule. It is asking pick point for printing column schedule. Here I am picking. It will generate the column cross section details for all the floors. The drawing will be generated to true scale. This is the layout plan. This is the footing schedule. This is the column cross section details. Zooming in. I am switching off the unwanted layer. This is the member numbers 1, 2, 3. For member number 1 we assigned C1 by F1. This is the step footing. We assigned 4 meter by 4 meter for first step and 2 meter by 2 meter for second step. Then pedestal for F1. It will generate for all the members. This is C2 by F2. We assigned 5 meter by 5 meter for first step, 2.5 by 2.5 meters for second step. Then we provided pedestal. This is the footing schedule. F1, F2. Size of the first step, size of the second step. This is the bottom reinforcement. This is the pedestal size. This is the pedestal reinforcement detail. This is the typical cross section of footing. This is the column schedule. C1 and C2. This is the size of the column, 300 mm by 600 mm. For C1 we assigned 4 numbers 16 dia, 4 numbers 12 dia. Bar mark also it is showing. For 16 mm it is showing dot, and 12 mm it is showing circle. Here it is showing master ring and one internal ring. For C2 we assigned 6 numbers of 16 dia, 4 numbers of 12 dia. It is showing one master ring and one internal ring and one hook. It will show for all the floors. It is up to 0 meter level, up to 3 meter level, up to 6 meters and 9 meters, that is terrace level. Like this it will generate n number of columns along with foundation layout plan, footing schedule and column cross section details floor wise within a short time.